Hello everyone, welcome to the session and welcome to my channel Aptitude Club. So this is the fourth session of the remainder series. I had started the remainder series a few days back and three sessions we have already done. First session was on basic remainder theorem and negative remainders. Second session was on Fermat's little theorem and the third session was on questions on continuous digits using basic remainder and Fermat's theorem. So three sessions we have done. We have taken up questions from a very basic level and we tried to understand how these theorems are applied in the questions. If you are new to the channel and you're watching this video for the first time, I would suggest please watch the previous three videos. I will post the links of those three videos in the description of the video, and also I'll pin it in the I section so you can check it out and do watch those three sessions because you will get an overall idea of how the principle of remainders it works. Remainders all of us understand, but maybe before this you would not have thought of remainders in this kind of a way, because when we usually thought of division usually has two results, quotient and remainder. We always focused on the quotient side of things, we never looked at the remainder side of things. But here we'll be discussing entirely on remainders. What's the principle, how it works, what are the properties, what are different theorems, what kind of questions are being asked. And that is why I started this series of remainders. I have created a separate playlist also on this channel. So if you watch the entire playlist of remainders, I can assure you that any question on remainders you will be able to solve, no matter easy, very easy, difficult, very difficult, you will be able to solve. So do watch the entire playlist, and after the video, if you like my way of teaching and if you like the content on the channel, do like and subscribe to the Aptitude Club channel. The purpose of the channel is to give you good quality content for your CAT and other management entrance tests preparation. जितने भी लोग क्वांट्स के लिए प्रिपेयर होना चाहते हो, I will try my best to contribute by doing some useful videos related to concepts, practice, strategy, so that you can benefit from those videos. So if you like the content on this channel, so do subscribe, and let's begin with today's session. So in the fourth session today, we'll be taking up Euler's remainder function. Okay, Euler's remainder function or Euler's totient function बोलते हैं, और Euler's remainder theorem, जैसे भी इसको तुम बोलो. So let's try and see what it is. So before getting into the theorem, पहले वो Euler's totient function उसको represent करते हैं, like उसको define करते हैं पहले. Euler's totient function is represented as this. It is represented as phi of n. Phi of n. This is Euler's totient function. What is phi of n? Phi of n is the number of natural numbers. Number of natural numbers, अगर definition देखेंगे, number of natural numbers less than and co-prime to n. That is the meaning of phi of n. It is the number of natural numbers less than and co-prime to n. What is the meaning of co-prime? Two numbers are said to be co-prime if their HCF is 1. Two numbers are said to be co-prime if their HCF is 1. Necessary नहीं है numbers prime हो, but if their HCF is 1, example 4 and 25, none of them are individually prime, but they are co-prime to each other. Co-prime is a relation. So phi of n indicates the number of natural numbers that are less than and co-prime to n. क्या मतलब है? एक example लेके देखते हैं. Suppose I'll take it for an example. I'll take n is equal to 18. And I'll see how many natural numbers are less than and co-prime to 18. I took a small number so that we can evaluate manually, and then we'll go to the formula. Is there any formula to compute this? Now, if we start with natural numbers, first natural number is 1. Is 1 co-prime to 18? Yes. 1 and 18 are co-prime. Can I take 2? 2 I cannot take. What you cannot take is you cannot take 2. Because 18, basically if you look at 18, 18 is 2 into 3 square. So any number which has got a 2 or a 3, they will never be co-prime to 18. Because they will share a common factor. So any number which has a 2 or a 3 will not take that. So 1 and 18 are co-prime. Next 2, 3, 4 we cannot take. 5 will be co-prime next. 6 I cannot take because 6 has got a 2 and a 3, so 6 and 18 का HCF 1 तो नहीं होगा. Then I'll take 7. I cannot take 8. I cannot take 9. I cannot take 10 also. I'll take 11. Then I'll take 13. Then 14, 15 you cannot take. 16 also you cannot take. You will take 17. So these are the numbers which are less than and co-prime to 18. They are less than and co-prime to 18. 18 के ऊपर तो infinite वैसे numbers आएंगे. But how many natural numbers less than and co-prime to 18? So I got there are 6 natural numbers. Thus I can write phi of 18 is equal to 6. This is the simple meaning of Euler's Totient function. How many natural numbers are less than and co-prime to n? Very simple meaning. और एक एग्जांपल लेके देखते हैं. Suppose I'll take n as let us say 20. How many natural numbers? तो 20 को पहले तुम factorize कर लो. It is 2 square into 5 to the power 1. So any number which has got a 2 or a 5 will not be co-prime to 20. So I'll start with 1, then 3, 4, 5 नहीं हो सकता. 6 also I cannot take. I can take 7. 8 I cannot take. 9, 10 I cannot take. 11, 12 you cannot take. 13, then 14 you cannot take. 15 नहीं ले सकते. 16 भी नहीं ले सकते. 17, 18 also you cannot take because 18 has got a 2. Then I can take 19. So I get 1, 2, 3, 4, 5, 6, 7, 8. So you get phi of 20 is equal to 8. That means there are 8 such natural numbers that are less than and co-prime to 20. I hope all of you understand the meaning. मतलब यूलर टोशन फंक्शन का मतलब क्या है. बट द प्रॉब्लम हियर इज दीज आर स्मॉल नंबर्स. तो मैं ऐसा एक एक करके काउंट करके आई एम एबल टू राइट. what if the number is a big number? I'll give you 500, 1020. तो ऐसे तो 1 से लेके 1020 we cannot keep checking and writing. So there has to be a formula to arrive at this. The formula भी is very logical. Okay, ऐसा अगर तुम देखोगे formula को you will try and understand. जैसे first example I took 18. So 18 first I prime factorized it and I saw that it is 2 into 3 square and then I said any number which has got a 2 or a 3 दोनों के दोनों co-prime नहीं होंगे. That means 1 से लेके 18 में there are 18 natural numbers but not all of them will come under this phi n. So I'll systematically remove the numbers that are divisible by 2 and systematically remove the numbers that are divisible by 3. So that is why I can write it in this way, that it is 18 whole into 1 minus 1 by 2, because 18 minus 18 by 2, it is the number of natural numbers that are divisible by 2, and then 1 minus 1 by 3. So 18 into 1 by 3 is the number of natural numbers that are divisible by 3. तो मैं systematically remove किया. तो देखो वही आएगा 18 into 1 by 2 into 2 by 3. So you get 6. So that gives us a normal formula that every time you are given a natural number, let n be any natural number. So your first step is to prime factorize n. n को तुम इस फॉर्म में prime factorize कर लो. a to the power p, b to the power q, c to the power r and so on, where a, b and c are prime factors. Prime factorization, I hope all of you understand, expressing a number as product of prime factors. कोई भी number का prime factorization means expressing the number as product of its prime factors. Expressing the number as product of its prime factors. So once you do that, एक बार n ऐसा आ जाएगा, then this implies phi of n. It's a very simple formula. I'll systematically remove numbers that are divisible by a, so 1 minus 1 by a. Then numbers that are divisible by b, so 1 minus 1 by c, and so on. So this is the formula. So given any number, you just have to do this. बहुत ही easy step. Prime factorize कर लो and then you apply this formula phi of n. Let me take an example. Suppose I'll say n as let us say 78. The first step is to prime factorize 78. तो 78 का अगर तुम प्राइम फैक्टराइजेशन देखोगे, कैसे प्राइम फैक्टराइज करते हैं? it is 239 and then 313. So 78 I can write it as 2 to the power 1 into 3 to the power 1 into 13 to the power 1. This is called as prime factorization. So phi of 78 डायरेक्टली तुम ऐसे कैलकुलेट करोगे n जो कि 78 है 1 minus 1 by 2 1 minus 1 by 3 and 1 minus 1 by 13. So 78 into 1 by 2 into 2 by 3 into 12 by 13. So 2 तो cancel हो गया 39 this is 2 so I get 24. Directly अभी मुझे value मिल गया that there are 24 such natural numbers that are less than and co-prime to n. Quite simple. एकदम standard process है. So first step is to understand what Euler's Totient function is, then how to calculate the Euler's Totient function. So simple process, prime factorize the number and then directly just put this formula. Why we are doing this, I hope all of you got it. When I'm doing 1 minus 1 by a, that means from n, I'm systematically removing numbers that are divisible by a. Then I multiplied 1 minus 1 by b, that means I'm removing the numbers that are divisible by b, and then similarly numbers divisible by c. So at the end, whatever is left, they will be not divisible by any of the prime factors, thus they are co-prime to the like original number. Very logical. See, whenever you read any formula also, I'm not saying that you need to know the derivation of every formula, but you should know the background of it. It definitely helps you think. Okay, it enhances your thinking ability when you come across a question. And that is what is needed. Okay, the more depth we have on a topic, the more chances we have to think and apply. Because how else do you develop the application skills? The questions are never formula based, that put the formula, get the answer. It doesn't work like that always. The exam is like testing a specific set of skills, that how well you are able to apply what you have understood. Doesn't matter तुम्हें बहुत पता है या नहीं, but जितना भी पता है, can you apply it? Okay, can you use your brains and be smart enough to pick the right questions, identify the questions which can be easily solved in the exam scenario. They are not trying to test that who has the highest like intelligence level in terms of quants. If you are someone who is naturally very good in quants, good for you, and you can score very high in the section, you should score. But then if you're someone who is a little afraid of this section, so my suggestion would be invest some time in it. Okay, do not run away from the topics, invest some time in it, take a genuine interest, read, try and understand, ask doubts, involve yourself. Then even after that, you will never regret, because you will score a 99 percentile anyways. Okay, when I'll ask you that out of 22 questions तुम 20 क्वेश्चन करके आओ और 19 questions 20 questions solve करो, that needs a lot of practice and talent and intelligence and what not. But if I say just 10 questions करके आओ out of 22, now that raises a big question, that if it is 10 questions out of 22, why are people not able to solve? What is going wrong in the preparation? That I cannot solve 10 questions from 22 questions after preparing for 6 months. So what is it that people fundamentally do wrong that I will not do? कहाँ पे वो गलत करते हैं, and which is the wrong approach they are following, and most of the people always do that. Okay, they don't realize but they do that, and at the end they find it difficult even to solve 8 questions, 7 questions. That's how the game is. 22 से 10 11 questions में 99 आ सकता है, and that should be your target. And उसको करने के लिए you will have to read all chapters equally and then select in the exam. What people do a mistake is they select beforehand and then they are stuck with what they have read. And if you get a difficult question from that chapter, you don't have a choice now, because you have skipped the other chapters already, so you don't have a choice in the exam. That's the wrong approach that everyone follows. So read every concept while you are starting your preparation. Be neutral to all chapters. Take a genuine interest in every area, be it arithmetic, algebra, modern maths, permutation, combination, probability, numbers, geometry, mensuration, trigonometry, coordinate geometry, doesn't matter. For you, every chapter is equal, and you will try and give you 100% in every chapter. Once you're through, then you can prioritize. Okay, I know all the basics, I have solved a good number of questions from every chapter, but I see that arithmetic is more important. I see that more number of questions come from arithmetic, algebra, numbers थोड़े कम questions आते हैं. Modern math I need not worry too much, वहाँ से ज़्यादा question नहीं आता, but I know the concept, so if any easy questions come I can handle. So nobody can stop you to get a 99% in that case. But if you have been selected beforehand, so you have a limited choice in the exam, and whatever you have read वहाँ से difficult आ रहा है भी तो you cannot do anything about it. Think about it. Okay, don't get very selective, and when you are reading, focus on understanding जो भी formula, especially in quant. जैसे ये formula दिखा तुमको, try and think the background. ये formula ऐसा क्यों हुआ? why is it is multiplied 1 minus 1 by a क्यों हो रहा है? Because that क्यों, that why question, when you keep asking, it will help you enhance your thinking process, and that's needed. You don't have to mug up the derivation, but of course if you understand better. ठीक है? So this is like Euler's totient function. Next comes Euler's remainder theorem. इसी totient function के ऊपर बेस करके Euler's remainder theorem. Now we had read Fermat's remainder theorem, and it was specifically for the divisors that are prime. But Euler's remainder theorem says for any number a co-prime to n, remainder of a to the power phi n divided by n is 1. For any number a co-prime to n, remainder of a to the power phi n divided by n is 1. Okay. So for an example, if I'll say find the remainder when let us say 13 to the power, जैसे यहाँ पे किसी के एक का 20 है तो 20 का 8 है, तो 13 to the power 17 is divided by 20. ऐसा दिया क्वेश्चन. So when you get this number, your first step is you take this as n and इसका phi n calculate कर लो. So how much is phi of 20? So it is 20 whole into 1 minus 1 by 2 into 1 minus 1 by 5. So 20 into 1 by 2 into 4 by 5. So you get 8. Once you get 8, then जैसे Fermat's theorem का principle था, it is exactly like that. What you do is you have to calculate this remainder of 13 to the power 17 divided by 20. What you do is you break it as 13 to the power 8 into 13 to the power 8 into 13 divided by 20. Why do you break like this? Because तुम्हें 13 to the power 8 divided by 20, remainder is 1. A to the power phi n divided by n. So n is 20 and 8 is your phi n. तो फिर यहाँ पे भी remainder 1 and here the remainder is 13. So finally you get 1 into 1 into 13. So the answer is 13. Exactly the principle of Fermat's, but Fermat's में divisor prime था and power was p minus 1. Here the divisor is n and the power is phi n. Actually Fermat's theorem is kind of a special case of Euler's remainder theorem, that whenever n is a prime number, then phi n is like p minus 1. So the theorems are almost similar, but Fermat's was only for prime number. अब Euler's theorem in general तुम कोई भी number के लिए use कर सकते हो. So it is like a special case. मान लो I'll take if n is equal to prime number is equal to p, this implies phi of n will be p minus 1. So look at Euler's theorem, and तो Euler's theorem जो है phi n by n, if n is p and phi n will be p minus 1, तो ये बन जाता है Fermat's and this is Euler's. समझ रहे हो? So if n is a prime number, Euler's theorem becomes Fermat's theorem, but principle wise it is same. और एक एग्जांपल देखते हैं. लेट अस से यहाँ पे मैंने 78 का निकाला 24, तो फाइंड द रिमाइंडर when 23 to the power 98 is divided by 78. तो whenever you see the number, तुम्हारा फर्स्ट स्टेप है ये जो नंबर है इसका phi of n निकालो. तो n is 78 which is 2 into 3 into 13. तो phi of 78 कितना निकालो? तो हमने यहाँ पे निकाला था phi of 78 is 24. Now just use this remainder of 23 to the power 98 divided by 78. So you can write 23 to the power 96 into 23 divided by 78. Why did I write 96? Because अगर 24 में रिमाइंडर 1 आएगा, 2 बार 24 लोगे तो 1 into 1, 3 बार लोगे तो 1 into 1 into 1. So any multiple of 24 also will give you remainder 1. तो यहाँ पे 1 आ गया. 23 into 23 is 529. 529 divided by 78 करोगे, फिर जो भी रिमाइंडर आएगा. I hope this makes sense. 529 को 78 से डिवाइड कर लो. 529 divided by 78. I don't think 7 आ सकता है, तो 6 आएगा. 6 8, तो ये आ जाएगा 468 आई थिंक. 32 plus 20 52 961 981 12 61 आएगा. 61 is our answer. So the principle of application is exactly like formats. All you need to do is जैसे ही number देगा, you find out phi n and then solve. Okay. So hope this makes sense. तो पहले Euler's Totient function आता है, and then based on that Euler's remainder theorem आ रहा है. Let us try a few questions. For an example, here it is saying find the remainder when 53 to the power 98 is divided by 120. So what is step 1? You take the divisor 120 and prime factorize. अगर 120 को prime factorize करते हो, 260, 230, 215 and then 3 5. So I get 2 to the power 3 into 3 to the power 1 into 5 to the power 1. And then next step is phi of 120 निकालो. 120 into 1 minus 1 by 2, 1 minus 1 by 3 and 1 minus 1 by 5. So you get 120 into 1 by 2 into 2 by 3 into 4 by 5. 3 5 50 into 30, तो ये आ जाएगा 4, तो you get 32. तो जब पावर 32 होगा रिमाइंडर 1 आएगा. तो देन अकॉर्डिंगली यू एक्सपैंड दिस. इसको अगर तुम अभी एक्सपैंड करोगे, इज रिमाइंडर ऑफ 53 to the power 32 into 53 to the power 32 into 53 to the power 32. तो हो गया 96 into 53 into 53 divided by 120. So every time 53 to the power 32 is divided, remainder is 1, 1 and 1. तो अभी बस 53 into 53 कर लो. 53 into 53 will be 2809. हाँ. So this divided by 120. फिर जो भी रिमाइंडर आएगा 2809 को अभी 120 से डिवाइड कर लो, बिकॉज रिमाइंडर हैज टू बी लेस देन द डिवाइजर. तो 122 are 240, फिर 409, 120 into 3 360, you're left with 49. So that is the answer. Quite simple. And जो लोग इसको पहली बार देख रहे हो वीडियो में भी थोड़ा तुम्हें नया लग सकता है, but trust me, you watch from the session 1 basic remainder theorem. That's the key to understand every remainder question. Basic remainder theorem, then Fermat theorem, then continuous digits. Now then you watch this, you'll find it extremely easy and you would have understood how the principle of remainders works. Once वो एक बार समझ आ गया, then doesn't matter question कितना भी difficult आ रहा है, you will figure it out how to solve. Okay, so very simple and pretty direct process to solve these kind of questions. Phi n निकालो and then just use the theorem directly. Let us see another one और एक question देखते हैं. Suppose this one, remainder of 77 to the power 51 divided by 36. Again the same thing. First when you see the number phi n निकालना है. So n is equal to 36. 36 if you prime factorize, so you get 2 square into 3 square and then find phi of 36. So 36, 1 minus 1 by 2, 1 minus 1 by 3. So it is 36 into 1 by 2 into 2 by 3. So you get 12. Once you get 12, then you can apply it here. 77 to the power 12, 77 to the power 12, 77 to the power 12, 77 to the power 12. हो गया 48 into 77 into 77 into 77. 51 हो गया. This divided by 36. ये जस्ट तुमको समझाने के लिए अभी लिख रहा हूँ, बट यू ऑल्सो नो दैट 51 है, 12 में अगर रिमाइंडर 1 है तो 48 तक रिमाइंडर 1 आएगा, तो यू कैन इग्नोर, जस्ट 77 टू द पावर 3 रहेगा. So in all these cases the remainder is 1. So 1 1 1 1 and 36 divided 77 में 36 डिवाइड करोगे, 36 to the 72, तो रिमाइंडर इज 5. तो 3 बार 5 आ रहा है, so that means it is remainder of 125 divided by 36. तो 36 into 308, तो आ जाएगा 17 आंसर. 125 में 36 डिवाइड करेंगे तो 17. इतना सिंपल क्वेश्चन है, सोच रहे हो. इफ जस्ट यू नो द थ्योरम, ट्रस्ट मी दैट एनी क्वेश्चन ऑन रिमाइंडर्स विल नॉट टेक मोर देन 30 सेकंड्स टू 1 मिनट, उससे ज्यादा होगा ही नहीं. एंड कैट में इतना भी लेंथी क्वेश्चन आएगा नहीं रिमाइंडर्स का. दैट इज व्हाई आई स्टार्टेड विद दिस. अ लॉट ऑफ पीपल बाय द एंड ऑफ द एग्जाम प्रेप दे आर अफ्रेड ऑफ नंबर सेक्शन. एंड बहुत लोग बोलते हैं नंबर समझ नहीं आ रहा, इट इज सो वास्ट, इतना डिफरेंट डिफरेंट क्वेश्चन आता है. तो हाउ डू डील विद सच एन एरिया? तो विल ब्रेक इट इनटू पार्ट्स. एक 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 कॉर्नर स्टोन्स बनाएंगे. जैसे रिमाइंडर्स एक हो गया, देन आई विल टेक अ सीरीज ऑन फैक्टर थ्योरी. इट्स वेरी इंपॉर्टेंट टॉपिक, वेरी कॉन्सेप्चुअल टॉपिक. फैक्टर थ्योरी कर लेंगे, एक साइड में रिमाइंडर्स कर लेंगे, और एक साइड में डिविजिबिलिटी साइक्लिसिटी उसको कर लेंगे. तो ये 3 एरियाज अगर तुम्हारे कंप्लीट हो गए, मोर और लेस यू विल हैव अ गुड होल्ड ऑन द नंबर सेक्शन. गुड होल्ड वहां पे आ जाएगा. देन तो देर इज नो एंड टू न्यू क्वेश्चंस. यू विल ऑलवेज 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 हैव न्यू काइंड ऑफ क्वेश्चंस. एंड इट्स ओके इफ 2-3 क्वेश्चन नहीं हो रहा है, बट यू विल हैव एन ओवरऑल सेंस ऑफ व्हाट द एरिया इज ऑल अबाउट. 70-80% times you will be able to solve the question, and that's very 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 good way of looking at a section. अगर 70-80% मेरा अच्छे से कवर हुआ है and I can solve anything, why not? Why not? And preparation of numbers also helps you in your understanding of other areas. That is one advantage of the numbers section. ठीक है, तो इसीलिए आई थॉट ऑफ स्टार्टिंग इट इन द बिगिनिंग. तो ये पूरा रिमाइंडर सीरीज एक बार तुम देख लोगे एंड टू एंड, यू विल फाइंड इट एक्सट्रीमली सिंपल to deal with any question on remainders. Okay, let us see this one. Remainder of 3 to the power 185 plus 5 to the power 185 divided by 77. Again same process. Number यहाँ पे तुम्हारा 77 है, so it is only 7 to the power 1 into 11 to the power 1. So 5 of 77. This 77, 1 minus 1 by 7, 1 minus 1 by 11. So it is 77 into 6 by 7 into 10 by 11. So you get 60. अभी इसे यूज करना है. So that means I can write 3 to the power 60 divided by 77. जो भी रिमाइंडर आएगा, it is same as remainder of 5 to the power 60 divided by 77. Same remainder 1 आएगा. And not just 60, any multiple of 60 में भी remainder 1 आएगा. तो 185 है, अगर मैं 180 तक रिमाइंडर 1 है, so I can reduce the numbers to this 3 to the power 5 plus 5 to the power 5 divided by 77. देख रहे हो, 185 से just reduce to 5 because 180 तक तो रिमाइंडर 1 ही है, तो why do that? So next time gradually with practice you can skip that step. So this is 3 to the power 5 is 243 divided by 77 plus 5 to the power 5. 5 to the power 5 चाहो तो तुम वैल्यू लिख सकते हो 3125 डिवाइडेड बाय 77, नहीं तो इसको फर्दर ब्रेक करके भी लिख सकते हो. एनी विच वेज इट इज कंफर्टेबल टू यू. तो 243 डिवाइडेड बाय 77 चेक कर लो कितना रिमाइंडर आता है. 243 डिवाइडेड बाय 77 करते हैं तो 77 31231, तो ये आ जाता है 12. एंड व्हेन आई टेक 3125 डिवाइडेड बाय 77, तो 77 4 है 308 आता है आई थिंक, कैरी 2, तो 45 आ जाता है. तो यू गेट 12 प्लस 45, यहाँ पे आ जाता है 12 एंड यहाँ पे 45, तो ओवरऑल आंसर इज 57. एज सिंपल एज दैट. रिमाइंडर ऑफ अ सम इज सम ऑफ रिमाइंडर्स, एंड में वो अप्लाई हो गया. So simple theorems. We'll take one theorem at a time in every session. I'll not overload you with a lot of information. One step at a time, one video at a time. अच्छे से समझो, make notes of it, write, and खुद examples लेके practice करो. Or if you are following any book or source, you can watch from there and again practice. And gradually you will learn that okay how this works. एक दो questions खुद solve करोगे, that would be like your eureka moment, and you'll understand okay this is how it works. एक बार वो फिगर आउट कर ले, देन यू विल बी अनस्टॉपेबल. ठीक है. So I hope all of you got an idea of what Euler's Totient function is and how the Euler's remainder theorem works. I explained you three very simple examples. So that is it from this session, and I hope all of you liked the class. And if you have enjoyed the video and you find it useful, do like the video and subscribe to the Aptitude Club channel. The purpose of the channel is to provide you good content for your cat quants preparation, especially LRDI. का भी आगे जाके I'll make videos for LRDI as well. So if you are new to the channel, I hope you enjoyed and found this channel useful. If yes, don't forget to subscribe to the channel, like the video, share it with your friends, and hit the bell icon so that whenever I come live, every day I'm posting one video, so you will get notified and you can watch. So thanks a lot once again for watching the video. Have a nice day everyone. Bye bye.